Hello everybody, in this video we're going to walk through doing the distances tab and then follow up with a video on the silhouettes. Okay, so to begin, let's create a new tab called distances. It could be anything you like, just be mindful that I call it distances. Okay, so remember the first thing we're going to do is start making those zeros. So 0, 1, 2, 3, 0, 1, 2, 3. And again, we're going to do this so that we have an array format for our data set. Okay. And we're going to actually stop at 99 because we start at 0. Okay. We're just going to shift down here because we're going to have our names going across here. Okay, so let's just go grab those names. Okay, a couple ways to do that, but we'll just grab the names. You can go in any tab you want that already has the names. That's not what's important. But what's important is we paste them, transpose the values so they go left to right, and then we're going to make sure it's all set up this way as well. Okay, and we'll drag down or double click down, make sure that you have a 99 for young, and then again a 99 for young over there. So let me ask you a question quick. Why do we have 99? We have 100 customers. Why is there a 99 as the last customer? Again, because we start with a 0, because that's what we do when we work with best practice array formats. Okay? So now we're going to do a Euclidean distance where we compare atoms to atoms, atoms to Allen, where they are in this universe of data points that we have. Okay? So let's go ahead and make sure you save your file. Let's go back to day 3, grab that formula that we've got. Okay? So we've done all these steps. We're going to grab that formula. Oops. Now keep in mind, a spot where some people have trouble is a couple of things. One, if you are referencing the matrix tab, that's great. Okay, that's great. But if you're referencing 4MC, just be mindful that you have to move over to L instead of H as your references because you have 4 extra columns here. Okay? So because I'm referencing matrix, H2 to H33 is correct, but if I was doing this on the 4MC tab, then I have to go L and then over there. So just be mindful of those things. Okay. Also be mindful that we have to hit Shift Control Enter because we're again talking about an array like the Euclidean distance formula that we did on 4MC tab. So bring that down all the way. If you wish, you can do color scales, and you should get zeros dragging all the way down. Okay, so that's the distances tab for you. Now we're going to look at the silhouette tab. Okay. Now for the silhouette tab, you are responsible for knowing what the columns are going to be called. Okay, so first things first, we have the customer or name. Okay, we also have the community, which is the data science term for cluster that they belong to. Okay, and then we're going to have we're at the cluster 1, cluster 2, cluster 3, cluster 4. Okay. Okay, so now we're going to have these in here. I'm just going to populate them in for you. Remember, distance from 1, 2, 3, and 4. If you want to do a word wrap, I didn't show you this before, but if you click on word wrap and then basically double click this, now you've got this here, but we're just going to delete that 5. I just went a little aggressive there. So we've got distance from 1, 2, 3, 4, closest cluster, second, my cluster, neighboring cluster, and silhouette values. Okay, so customers, we can grab that list from here, pop this in, go back to our 4MC and grab their assignments from here. Okay, grab their assignments. And remember, we got paste special values because they were originally going left to right. Okay. So now what are we going to do here? Okay. Well, I give you the formula, but we're going to do some averaging. Okay. We're going to take the average if function from 4MC. We're going to look at all of the cluster assignments and average Adam's score. Right? Okay. So let's go look at what we did. 4MC, row 39, which is all of these clusters. It's looking for all the people in ones that have ones. Okay. What is their score? Or what is Adam's score compared to them? Because remember, that's what we're interested in. Now we have to hard code this, otherwise we can get the same answer. Okay. Closest cluster is the min distance one, whichever one's the minimum. And then we've got the small function, but we're going to look for the second closest. So we're going to put a 2 there. Okay. We're going to use the index function. Okay. What is the array? It's this one. We're going to look for the row number that corresponds to community. Okay. Drag that down. Neighboring cluster. This is that if statement. If I equals closest cluster, then the neighbor is the second closest. Okay. Otherwise, it's my cluster. Okay. Drag that down. A silhouette value is going to be this formula here. Show you where it is. Okay. It is going to be j minus I. J minus I. Okay, we want to do that math first because we're going to do a division problem. In the order of math operations, we'll take those two numbers. So we can do the max of these two numbers. And we will get a percentage. Okay, so double click that down. What is our average silhouette? And here we got a 17.2. Okay. So not too bad. It could be better, right? The higher the number, the more positive, better. But we definitely do not want negatives. Do we have any negatives in here? No, we don't. We have only zeros. Okay. So our cluster was successful. Okay. Could it be better? Yes. I want to knock down that minimum distance a little bit more. You know, maybe I could do that, you know, here. Run this a little further into the ground a little bit, etc. Okay. Okay. Remember, why do we do L to DG? Well, it's because that's where it stops. Our L right there, all the way down to DG. Okay. Just look what the average function is doing. It's going to take all those numbers, all those cluster assignments, look for the one, and every time there is one, it's going to average that number. So basically, it's going to take a number like this set and run an average. All right. So that's how you do the silhouette. Now, a bonus round to this could be, let's create a column chart. Or even better yet, for speed, we like to create, a bar chart showing all of the different silhouettes. Like we've got a couple that are pretty good. Like this customer here, right around 55, silhouette's 50%. It definitely belongs in that cluster, and it's very unique and well supported. So you might want to look at this in terms of a histogram. I would not put together a histogram, but you could look at it in terms of that. See if there's a pattern, like, oh, most of your silhouettes around here. I mean, you could run a standard deviation as well, right? So lots of different things that you could do here. stdev, grab all these numbers. Okay. So we got an average of 0.17, but we got a silhouette standard deviation of 15. So that means we could have, generally speaking, a range from 0.32, where most of them fall, or we could have a range ending at 0.017. So that's quite the range. So you want to look for the intensity. We've got a lot of outliers here, but a lot of our results, are they really tight over here? What's the story there? It seems like most of them come up to here, or somewhere in between with some outliers. So you might want to just study it that way as well, just to see how healthy it is. So, because I could have a silhouette value of 99, okay, and now look what happens. Okay, so the further away I get, I could have a bunch of 99s here. Obviously, because they're all in order, it makes a goofy little block here. But imagine I've got a 0.99 here, here, 0.99. Before long, my graph's going to really show some outliers or separation from the pack. So very useful to also run a column chart just as a tip, just to inform your boss or just to visually show you how far apart the data sets are. Okay? So very good.